right, so this section is on functions. Before we start with functions, let's talk about a relation. A relation is a set of ordered pairs. Pretty much the relation is the correspondence between x and y values. So when we want to talk about domains of relations, the domain of a relation is the set of all first components of the ordered pairs, or in an ordered pair, the first component would be your x values. The range of a relation is technically your y values, or all of the second components of the ordered pairs. But now if we want to talk about the function, a function is a relation in which each first component of an ordered pair corresponds to exactly one component of the second component of the ordered pair. So if we want to talk about some more characteristics of functions, just you need to remember that each element of the first ordered pair must be matched with one element of the second. Also, that some of the elements in the second ordered pair may not be matched with an element of the first ordered pair. And then also you must remember that two or more elements in the first ordered pair may be matched with the same ordered pair from the second set. And guess what better way to do that is to give you an example. So for the first part, I have my input values and my output values. Technically, your input values are always going to be your x values, and your output values is always going to be your y values. So in order for a function to work, you have to put something in and get something distinctly out. So it's a little bit unorthodox, but the best way for me to explain how functions are and the rationale behind it is to use people. Functions is like a double standard. I can't exactly explain why it's a double standard, but that's just the way some things are in the world. So let's say that Lisa goes with Tom, Tina goes with Dre, Bay goes with Harry, and Susie goes with Trey. We would consider this to be a function, all right? But if I change this a little bit more, let's say that Lisa goes with Tom, Tina goes with Dre, Harry goes with Bay, and let's take Trey off, but Susie's left by herself. We would consider this not to be a function because Susie is all by herself. For some reason, it's a double standard in the world if a woman is left by herself. But if I take Susie off and put, who is this, Trey down here, this would be considered to be a function. It's okay that y is by itself. It's just not okay that x is by itself. Let me give you another example of a function. Let's say that we have, who was this, Susie? Let's say Lisa's going with Dre, Tina's going with Tom, Bay is going with Trey, and Susie is going with Harry and Dre. Because Susie is going with two people, this would be considered not a function. It's not okay if a woman is going with two individuals. She's a little bit out there, shall we say. But if I change this up all the way completely, right, and I take all of these young ladies off, right, let's say, no, let's put them back on, Susie and Bay. Let's say Dre's going with Lisa, Dre's going with Susie, and Dre is going with Bay. Dre is the man. He has 3 females. This would consider to be a function, okay? So you just have to remember that it's okay if my y does 2 things or 3 things in common, but it's just not okay if my x value does that. So the best way for me to explain that is if your x value repeats, then it's not a function. If your y value repeats, then it can be possibly a function. Each member of my first component has to match with exactly one of the second. So functions numerically. If I'm talking about these ordered pairs, I have to look and see if any of my x values repeat. None of my x values repeat here, so I would consider this to be a function. And then also you may be asked to, with the function, list the domain and range. Well, the domain of this would be all my x values, so that would be 0, 1, 2, and 3. My range of this would be all of my y values. So that would be, let's see, 0, -1, -2, and 2. I have it a little bit out of order there. But this would be considered a function because nothing repeats for my x values, right? So now here, the second one, I have 2, 4, 2, 5, 4, 5, 1, 5. So because my x values repeat here, this would be not a function, okay? But just for sake, we're going to say, what is the domain? Well, the domain of this would be, we do not repeat values, so that would be 2, 4, and 1. And my range of this would be 4, 5. Okay? So, moving along, that's functions numerically. That's talking about just with ordered pairs. But then when we get to algebraically, we have actual equations, all right? And so I forgot to mention that y equals to f of x is our basic standard form for a function, okay? But we'll discuss that a little bit more in detail later. So if I'm trying to determine if an equation is a function or not, right, then I would always solve for y, okay? So in this case, this would be subtract the x from both sides, or x squared from both sides, and y would equal to negative x squared plus 1, right? So I have what? Even though I can put in some x values, I'll get exactly one y value here. But now if I try to solve for here, this for my y, I would add an x to both sides, right? And then I would have y squared equals to x plus 1. Well, in order to solve for something squared, I would have to take the square root of both sides, and y would equal to the plus and minus square root of x plus 1. So because we don't know which one is supposed to be working out, this would be not a function, okay? But we'll get into more details later into the class. The best way that I put it to simplify that is if you have a y squared, then it's not going to be a function. If you have an x squared, then it will be a function, okay? So evaluating functions. So in order to evaluate functions, remember I said f of x equals to y. Well, wherever you have a x, or whatever their f of x is, you plug in that number for x. So this is f of 2. So to find f of 2, I will plug in 2 wherever I see the x. So that would be negative 2 squared plus 4 times 2 plus 2. Well, 2 squared would give me 4, but there's a negative out here. So that would be negative 4 plus 8 plus 2. So this will give me negative 4 plus 10, which will give me a positive 6. And then that would be my first one that I'm evaluating. The second one is f of x equals to, f of x is x plus 1. So that requires a little bit more detail. So wherever I see x, I am going to plug in x plus 1 for this particular function. So this will be a negative x plus 1 squared plus 4 times x plus 1 plus 2. Excuse me. So technically this x plus 1 squared means I would have to FOIL that, because this is saying negative x plus 1 times x plus 1, and then I'll go ahead and distribute this for you. This will be plus 4x plus 4 plus 2. So if I FOIL this, this will give me x times x, which will be x squared, x times 1, which will give me 1x, plus another 1x, plus 1. So I also had one on the outside of here, a negative sign. So that means I need to distribute this minus sign to everything in this parentheses. So this will give me a negative x squared. Cassandra. So this will give me a minus x and a minus x and a minus 1. Now also, before I move on, can I combine my like terms? Sure. So these two negative x1s, or 1x, will give me a negative x squared minus 2x minus 1, and then I bring down my 4x plus 6. So can I combine some things together now in this line? This negative 2x and positive 4x will give me a positive 2x, and then I have a minus 1 and a plus 6, so that gives me a positive 5. And then I have evaluated my function for f of x plus 1. This is part 1 of the video for functions. We have another part, so stay tuned. Thank you.